Good afternoon, everyone. On behalf of all of us at the National Glass Association, thank you for making time in your day to join us for today's Thirsty Thursday, a special feature of a presentation given live during the NGA Glass Conference Long Beach, which occurred in January this year. It received high feedback and the content is important and timely to our industry discussions of late. We're glad you're choosing to join us today for it. Registration is now open for our next NGA Glass Conference taking place July 18th to 20th in Northbrook, Illinois, on the northern edge of Chicago. As our summer meetings typically entail, there will be a heavier focus on committee work and updates, and we're working on setting up 1 or 2 facility tours for you, so stay tuned as those plans develop. NGA is excited to announce the publication of its new Glossary of Architectural Glass and Glazing. From A to Z and every letter in between, this glossary is an invaluable resource for industry veterans and new hires alike. Sorted in alphabetical order for easy reference, this glossary is the only comprehensive list of its kind, covering 1,800 industry terms used in the industry. Visit the NGA homepage, glass.org, to learn more, or visit tinyurl/NGA glossary to be taken directly to the webpage. This course is accredited by NGA for 1 hour of AIA elective credit. Learning assessments for the AIA credit and certificates of completion are available upon request. Simply email sarah@glass.org as listed on the screen. I'm now pleased to introduce our speaker. Stephen Selkowitz is recently retired as Senior Advisor for Building Science at Lawrence Berkeley National Laboratory and is now a consultant and advisor to global building industry clients. He has extensive technical expertise on advanced glazing and window technologies, building facade systems, daylighting designs, and integrated building system solutions. Over his 40-year career at LB&L, he started and led the Windows and Daylighting Group and served as head of the Building Technologies Department for 25 years, partnering with industry to develop and demonstrate new technologies, systems, processes, and design tools that address energy, sustainability, and occupant comfort.
So you usually start with a picture, right? So I thought I'd give you a time lapse just to prove on the left there. That's me in junior high school, experimental boiling water reactor. I was into low carbon energy way back when, before it was popular. And then there's a sequence there. Mostly what you see is a change in hair length and amount and all that kind of stuff. Right? But so I want to. I was asked to talk about IGUs, but I want to talk about them. Sorry. In the context, it was asked to talk about in the context of sort of carbon and energy, zero net energy. So I'm going to bounce around a bit between the techie stuff and the big picture strategy stuff, and hopefully I'll stir up. I know it isn't. It is late in the afternoon. I'm not going to throw anything, but maybe stimulate a couple of responses later. I'm happy to follow up. I'm also going to throw a lot of stuff at you in the slides, far more than you can absorb in my 30 minutes, but they'll all be available, and you can always contact me directly and I can send resources and stuff. So we have these major energy and carbon challenges now. The COP26 meetings a few months ago reinforced all those issues. This line of crisis is a terrible thing to waste has come up before. There is a crisis. People have different views about how bad the crisis is. I don't know if you've seen the Don't Look Up movie, but we won't go there. That's for talking about over drinks, maybe. What I was mostly intrigued with in the last 4 or 5 days, though, is I see the NGA logo here, this glass can save the world. Right on, you guys have it right. And the question is, can save the world, but how are we going to do that? And this, talk is a tiny piece to maybe explore what some of those challenges and issues are. Just a slide or two to remind you on the left what's going on in the world now. If you lived in California for the last 12 months, it's been a pretty terrifying time with the fires. The pictures on the right here are what the planet might look like in 2100 with the sea level rising, I don't know how many feet, but it would be a pretty big change. It costs someone an awful lot of money to deal with those kinds of changes. So let's try and stop that from happening, and that's the carbon problem, right? And so the challenge here is that if we're going to address carbon as a nation, as a globe, we need to address both operating and embodied carbon, but buildings are about 50% of the problem. Frequently, you see the number is more like 40% for energy, but that's the operating energy. If you look at the embodied energy and carbon in construction, it pops up into the 50 range, and it varies by country, but in round numbers, it's something like that. So if we're going to solve the big picture global and national energy and carbon problems, buildings have to be part of the solution. Part of the problem now, they should be part of the solution. And there's a whole, I mean, the good news is there's a whole host of things that we can do about it. And glass and windows are going to play an important part in that. So lately, in the last 6 to 12 months, lots of organizations at the global level, at the national level, the state level, this is NYSERDA, are coming up with plans of how do we get to 2030, 2040, 2050, and get to some variant on carbon neutral or net zero or half reductions in carbon. There's a whole variety of different flavors, but the thing that characterizes all of them is that they're big changes in business as usual. And what's interesting, this is one study. So the first thing it says, maximize energy efficiency. I mean, there's a lot of, we're going to build more windmills and build more PV power plants, but the first and most important thing to do is make sure that everything we do in housing, but other areas as well, is as efficient as it can be. And sure enough, the middle or the lower red arrow there, windows are part of this. So they recognize that if we're going to come up with better buildings, we need better windows. The emphasis on efficiency has some history behind it. This is from 1965. This is a 40, 50-year time frame. The blue line in the middle is actual US primary energy use. And it rose a fair amount at the beginning, then flattened out. That gray stuff up there is, had we not had efficiency over the last 30, 40 years, that's where energy would be now. And the gray part is essentially what we've saved by blowy windows and insulated water heaters and all that good kind of stuff. The little piece on the bottom there is PV and wind and all those other good new non-carbon sources. So they're rapidly growing. I mean, they're growing at a very fast rate, which is great. But the biggest savings historically have been by being efficient to start with. And so that's part of the theme here. Keep doing that. And so we're not the only ones thinking about that. We had a discussion at lunchtime about what's going on in Europe. Europe is, generally speaking, ahead of us politically anyway, in terms of thinking about what needs to be done and why. There's all kinds of interesting reports out there about the role of buildings in a climate neutral Europe, and then taken from Glass for Europe. This is a report they did. Europe set these targets of so many megatons of savings. And this study says, if you retrofit all the buildings, or if you retrofit all the buildings by 2030 with what's in the market now, you save the amounts in the top there. If you retrofit all the buildings with improved technology for windows by 2050, you save even more. And the bottom line is, glass could provide about 1/3 of all the savings that are needed or wanted in Europe if you do the things we're talking about here. So, that's maybe a model for what we should be doing in the US to try to point out to policymakers and others what the options are. So this is part of my thesis. If you've heard me talk before, I've said this so many times, it's probably boring, but we can do a much better job with what we have. We can get to the point where the facade, the glazing system can be better than, equal or better than an insulated opaque wall, essentially for any climate in any area, in any orientation. Now, that's a techie statement to make. It's not going to be easy or hard or maybe cost effective. Sorry, not easy or cost effective, but it can be done. It technically can be done. I can show you how to do that. We've done a bunch of models and simulations of what this might mean. This looks at all the windows in the commercial sector. And if you total up the total energy impact of those windows, today it's on the order of $20 billion a year in energy. If you then go through a list and say, well, what if we put in the best products? Or if we put in the typical products today, if we put in all OE, so we're magically changing every commercial building with all OE, all dynamic, all highly insulated. Just go down the list there. We basically make that $20 billion cost get lower and lower and lower to the point where it meets the zero line and then goes to the left. And now we're actually we're providing net energy to the building. And I threw in the bottom there daylight benefits from the electric lighting and putting PV in windows and all those good things. So you can go from a net cost of 20 billion to a net savings of 15. Of course, that's if you can magically change every building in the country, and that ain't going to happen, as they say. So we do need to pay attention, or more attention, I think, to the properties of those windows, the performance of those windows. And in the upper left here, there's the energy carbon stuff. That's the theme of this talk anyway. But for the last 2 or 3 days, this issue of people and comfort and productivity and daylight comes up over and over and over again. And that's good. It's coming up in the real world all the time. We need to be paying more attention to that. In general, the things that you want to do in those areas are consistent with what you want to do for energy and carbon savings as well. In addition, on the right-hand side, if you're an engineer or an architect, you have to worry about all those other mundane but critically important issues as well. So that's why, to some extent, this challenge of coming up with the right windows and glazings is tough. It's not easy. So what I'm going to do, I'm just going to look at a piece of the problem today, just really focusing on the heating issues. There's lots of other important things that need to be done here if you're going to end up with a building that's net zero. You could, if you screw it up, you could end up with a building that has very low heating energy in winter, but is terrible in summer. That's obviously not what we want. And then my other theme here is going to be, although I'm talking about the bits and pieces, the insulated glazing parts, this is really a systems problem. If you've seen me talk before, I've shown variants of this slide. There's a lot of moving parts to the problem, and you don't have to deal with every one of them on every project or job, but they're all there one way or another. All the stuff in the middle and the right is other building systems, and so there's all the pieces on the left that are the pieces and parts of the facade, and then there's the challenges of how they integrate. For example, how the daylight control and the glazing deals with the smart lighting. You don't dim the lights or turn them off, you aren't going to save any energy. So this integration issue is I think, is a huge challenge. And we talk about integration in terms of spacers and glass and frames, but I'm talking about it, bringing in maybe an automated shade, bringing in daylight sensors, and then bringing it into the rest of the building. And this is a theme that's been picked up in the industry. Is Rick around here somewhere? I've used this all the time from Old Castle. This is a real challenge. It's not easy to get all the parts together and make them work at the same time at the right time. And this is between, my theme here, of course, is from the IGU to the facade, but from the facade, excuse me, to the whole building. So one of the most important, there's a lot of practical reasons for doing this, but my reason comes back to how much can you afford to invest in energy efficiency and how do you pay for it? So here's a different version of my integrated systems problem. And I'm going to look on the left here at the facade. I want to invest more. I'm arguing I want to go to maybe triple glazing and smart glass. That's going to cost more. But if I move to the right here, I'm going to spend money on the heating and cooling system. And these days, I'm going to spend money on either new parts of the grid or PV or wind power or whatever, battery storage maybe. I'm going to get to a carbon neutral building. So I'm spending money in multiple places. And the simple theme here is that if I invest more on the left, I can take money savings from those heat pumps and maybe from the PV and the stuff on the right. And we've been involved in projects where they've gone through and actually calculated out. I'll give you one example later, where it's actually cheaper from a building's point of view, cheaper to put in better glazing because it saves more money elsewhere. This is first cost I'm talking about. Is an operating cost savings that's going to happen as well anyway. So there's a lot of talk now. If you're going to get to 2050, and again with the savings that we need, you have to address existing buildings. You can't build your way out of this problem with new construction. Something like 50% or more of the buildings that will be in 2050 are here now. And most of them, unfortunately, are single or maybe double glazed. So there's a lot of people now thinking about how do you retrofit? And there's this theme called deep retrofit. This is a report published recently by ACEEE, the American Council for Energy Efficient Economy. And they say, okay, strategy one at the top is you do everything at once. You've got money and expertise and you figure out all the things to do like I've been talking about, you do them all at once. More plausibly, when time and resources are limited, you go through a step process. And the critical thing here is you do the envelope first. It's dumb to go in and put in a new heating plant that's sized to meet the existing crappy envelope and then go back in later and change the envelope. And the key point of this is if you do the envelope first, you downsize the HVAC and the money you save can help out there. And there's other variants here as well. There's some intermediate ones as well. So there's this challenge of getting the technical piece of it right, but getting the business solution, the construction solution right at the same time. And I'm not going to go into some of the details here, but the challenge is sort of making these two parts of the problem really work as an integrated system. I'll come back to some of this later. So I want to spend a chunk of time now sort of drilling down onto the IGU world, talking about, and so I'm just talking here about glazing properties, which is a subset of the facade, which is a subset of how you put it into the wall. You were talking before about thermal bridges and all the different pieces and parts there. Again, it's a complicated problem, but I'm going to look a little bit at, can we make the IGUs, the glazing themselves, much better thermally? And we have some levers to pull here. Right? We can play with coatings, with glazings, with the glazing system, and to some degree the whole building. Sort of talk about future history of insulated glass. This is my fork in the road here. You know, we've come to a place where we have to go to the left to go to the right, and what are we going to do about sort of solving the insulating glass problem? So I'm going to spend a little bit of time looking at some housing issues with glass because I have a lot of data on that. The underlying issues are similar on the commercial side. There's about 48 million homes out there out of 100 million plus or minus that are largely single glazed, 20 to 30 million a year being retrofit, but that's out of a population of 1.4 billion. So there's a huge opportunity there. In new construction, you might say, oh, well, that's okay, we have it solved now. We're using low-E double in new construction. But with the new IECC code, look at the numbers here. In a typical house that meets IECC, the windows are 8% of the envelope area, but 47% of the peak heat loss. And that's, I mean, windows have gotten better, but the rest of the building got better faster. I mean, ceilings are R60 now. So that's a challenge and an opportunity. Now, that's not to say that some people aren't using triples or aren't doing better elsewhere. We've done some surveys around the US. People who are doing zero energy homes, for example, about 2/3 of them, these are 30 projects. Part of the group I work with went and interviewed builders, and about 2/3 of the builders were using triple glazing. We talked to the passive house world. A good part of that, of those buildings are triples as well, especially in northern climates. So the challenge here is, why haven't we made more progress in triples? And so here's my little universe of glazings. The ones in green here, the sort of the world of double with different flavors of low-E in different places with gas fills, this represents 80 to 90% of the market. The two I want to talk about, I want to talk briefly about everything on the upper right there, what I'm calling emerging and future, and then really focus more on triples and two different flavors of triples, a conventional triple on the lower left and this so-called thin triple in the middle here. So one set of emerging tech is VIG, vacuum insulating glass. These products have been around in limited form for 20 years. There's some good products out there now, some very successful projects, but not a lot of market impact at the moment. A lot of new buzz in terms of new hybrid designs for windows, new R&D, new generation VIG, which hopefully will be cheaper. I mean, cost is always an issue here. So there's good news coming here, but it's not here now. And if you wanted to plan a strategy for the next 5 years and address tens of millions of windows every year, VIG isn't going to be ready yet. And yet is the operative word. It's a chicken and egg as well. If the market is out there for tens of millions of low U value windows, then investments will be made faster and sooner in VIG plants. So all the stuff is connected. The other area is aerogel. How many of you have heard of aerogel before? Everybody's heard of gel. Probably a bunch of the startups have come to you guys and said, hey, I got the latest, greatest, best thing and give me a little money. And so I've been involved in this stuff since 1980. And it's wonderful stuff. As a scientist, it's wonderful stuff. Solid smoke is the way it was first described. The lightest material known to humankind. But DOE has been putting R&D money into it for decades, and there aren't yet real windows. Now, in the last couple of years, more funding was put in, a couple of new players have come into the market, and I think I heard from Tom recently that one of them looks like they might have something that looks good, but frankly, I've heard that before. It's not a statement on them. But I should mention on the lower left, there are products out there now. These are granular aerogels that are diffusing. And so they're highly insulating, but they're granular and diffusing. So if you want that product, it's available from multiple sources. If you want a clear pane of aerogel, you're going to have to wait a bit more. So I'm going to focus here on the options that are on the market now, which is basically flavors of multiple glazing. So I'm going to bounce, back and forth a little bit between the residential side and the commercial side. Frankly, I have more data on the residential side, but again, the underlying technology for the IGUs is pretty much the same. So if you look at the CPD, the NFRC certified product directory, this is U value along the left scale here. So you see the 0.2 U value over the blue there. Those are the triples. And then you see the doubles at sort of 0.3. And it looks like, well, there's a lot of good triples there in that product directory. But if you look at what's actually in the market, so this shows from 1970 up now, R2 normal double glazing is the solid line. The low E world is the dotted line, and triples are kind of hugging the bottom axis there, and they have been for 20 years now. 3% market share is what Ducker thinks it is now. I'm guessing it's less in the commercial space. So not much has happened. It's not that you can't build a triple. In much of Northern Europe, everyone builds triples, in Germany, places like that. So the question is, why don't builders in the US buy into that? And we've interviewed some of them, and this things we get back on the left here. They're too heavy, they're too wide, they're too expensive. And because they're too expensive, they have a long return on investment. So we looked at that and said, well, can we come up with a triple that's not heavy or wide, so it will fit in the existing pocket of a normal US domestic sash or domestic window sash, which is sort of 3/4 inch IGU, and actually deliver the performance. And we actually thought about this a long time ago. This is a patent I was one of the co-inventors on in 1991, long since expired. Technically, it would work like a charm. The problem was in 1991, you couldn't get the thin glass that is in the middle there, and the Krypton gas. Well, Krypton was available then. It wasn't cheap, but it was available, but you couldn't get the thin glass. About 5 years ago, I went back and looked at it again, and courtesy of your cell phone and your laptop and your TV, all of a sudden now there's a lot more thin glass around, and it's a lot cheaper. And so we looked more carefully at this, and we thought there was an opportunity here to get to triple performance, again, roughly an R5 window, a 0.2 U-value window, by packaging it in the existing glass package that was used in most of the residential sector. This shows on the right the sort of basic concept of the thin glass in the center with a single spacer. The other reason to have a single spacer is you only have 2 pathways possible leakage, but there's no reason why you can't make the thin glass as a center layer here in the middle. And some of the designs that partners have come up with, notice the one in the right talks about a 0.7 to 1.2 millimeter center glass. The one in the middle is 1.6. 1.6 is made by, I think, all of the primary glass guys now. The 0.7 to 1.2, that's more of a specialty product at the moment. I'll come back to that in a second. So a couple of years ago, I got hired to help someone kind of lay out a game plan or a plan of how to get to a space where we had cost-effective triples widely available. And there's the plan. And I was going to say, and I'm going to take you through it, but I'm not. But there's a 60-page report that I will be happy to point you to or send you to that talks about that. But in the meantime, what we've done is we've engaged with a variety of partners on the left of the window guys and the right of the supply chain. And they've developed a bunch of interesting products out there, somewhat concept, somewhat real products. There's been a bunch of buzz in the industry, some of which has come from places that you guys are involved in here, sort of sources. And it's moving ahead slowly, but the underlying issue, we're not committed to the thin triple per se, we're committed to triples, and the underlying problem is just not this huge market push. So let me drill down a little bit more on what's going on and why. So the first thing to comment is that you get, with the triple, you get about an R8 center glass. So I'm trying to be careful here between, I'm going to bounce back and forth between IGU center of glass properties and window properties, okay? So in the IGU center of glass world, a triple gives you R8. If you've got a slightly larger glass package, like an inch, an inch and a quarter, you can put 2 pieces of thin glass in there, you get an R14, which is roughly the kind of target that some of the new VIGs are looking for. So that's great news. That says that you can get an R14 center glass with a VIG, with a quad glazing here. And then, of course, you've got to package it in a sash and frame and all the rest of it. But that's the starting point. Now, GSA recently on the right here field tested in some office buildings in Colorado, a bunch of quad glazed windows. And they reported great performance and fast paybacks. The fast paybacks, of course, I mean, they saved a lot of energy. The payback piece depends on what kind of pricing they were using, and I don't know those numbers. But the good news is they work. Of course, there's no reason why they shouldn't, but they seem to work just fine. The building owners were happy. Comfort was an issue, which I'll come back to in a minute also. And I do want to, again, clarify the IGU issue, center glass IGU from sash and frame. This is a worse problem on the residential side when you've got a lot more fractional area of sash and frame. But just as a qualifier, I'm going to show you a couple slides now where I talk about window properties and IGU properties. So that's why I wanted to make that distinction. So here's a plot. On the left-hand axis is the center of glass U value, and on the horizontal axis is the window U value. And the bar in the middle with the tinted color, that's a 0.22 U value, window U value, and that number is there because that's what Energy Star wants to change northern value to. I'll jump ahead for a second. Energy Star is in the process of changing all of their required values. The northern zone, which is about 40% of the country, we hope in the next year or so, I think this was reported on earlier yesterday by Tom, it looks like they're going to go ahead and pick 0.22 as the magic number. And from my point of view, that's great because that's going to require the industry to go to triple almost always. And so all the things that we talked about that you could do or might do or can do, we hope that they'll actually do it to meet that requirement. But this shows that there's a whole wide range of things that you can do out there in terms of getting values at 0.22 and below. You can get down to 0.2, 0.19, and the rest of the sort of the scatter here gets to the spacer being used and the sash and the frame being used. So there are a bunch of steps in getting, and this new Energy Star stuff would come into play in 2023. There's a bunch of things that have to happen in order for the industry to be able to deliver products, at some scale by 2023. The good news is we've got a year and a half maybe to make those changes. And I want to just walk through a little bit of what you can glean from the current NFRC certified product directory in terms of what's out there. So we did a search. So Robert Hart, who leads this whole effort now at Berkeley Lab, did a search on the CPD library or the CPD database. And you can look at, for any given, say, window type or any given U value type, what types of spacers are being used. So this is just a plot showing some of the different spacers used in a wood frame, a vinyl frame, vinyl foam frames, different choices and so on. This is a little more interesting. This is showing triple glazing. On the horizontal axis is the IGU width. So I've got 3 spikes there, right? Mostly it's 7/8. It's probably a holdover from the old doubles. Then some 1 inches and some 1 1/4. The vertical axis is just the number of entries in the CPD. And you have to be careful because there's hundreds and hundreds of entries here. But remember, the CPD is a listing of what a window company could make, but not what they make and sell. Huge distinction there, because if you look there are thousands upon thousands of products, triple glazed products listed, but remember the market share is 2 or 3%. On the right-hand side here, sorry, a little bit hard to discern, but this is kind of a heat map showing the U factor for each of those different widths. So on the width that corresponds to the 7/8, you see the brightest color. Most of the units are there, and you see that the brightest green in the middle, can I point to that? I guess I can't. It's about at 0.25. 0.25 would not be adequate to meet the current Energy Star requirement, the proposed requirement. But if you go to the right, to the 1 inch and the 1 1/4, you're easily down in the 0.2 and the 0.2 range. Let me show you that slightly different way. I think this will be easier. If you're using a 0.75 IGU, I've got double on the left, double with too much touching, double on the left, double surface 4 low E in the middle, and triples on the right. And I've got my bands across the middle there. I've got my target, my window target of 0.22. And you can see that the double glazing doesn't make it, it's too high. The double with surface 4 low E almost makes it. And the triples, some of them make it, some of them don't. And the spread between top and bottom there in blue is between argon fill and krypton fill. So here's the challenge. This 0.75 inch IGU, the 2 air spaces that are left when I put in my glass are pretty small. And they're so small, they're roughly 1/4 of an inch, that's suboptimal for argon. So the argon numbers are pretty high. Krypton is much better. So you see a huge improvement with krypton. Now, the other thing you probably can't quite read in the bottom, those are all glass thicknesses. So we're looking at units that are everywhere from 2 and 2 millimeters to 4 and 4. On the right-hand side, that 4 and 4 millimeter glass, there's so much glass in that 3/4 inch IGU that there's not much room left for the airspace. And I see people are paying attention and trying to discern it. I get that there's a lot of stuff here. Let me just go by comparison. So this is 3/4 of an inch. So kind of blur your eyes a little bit. Watch what happens when I go to 1 1/4. big change, right? Actually, the doubles and the double surface 4 low E, they don't change much, but the triples now, all the triples are below the lowest end, and the difference between argon and krypton is hardly there at all. So basically, one of the challenges with the thin triple we're working on is krypton has gotten to be expensive and a challenge. If you're using an IGU that's a bit wider, you don't need krypton. That's the bottom line. So we get asked all the time by partners that read a report or get a study or hear something about, how can we push this thin triple thin forward? Glass supply, the supply is there. If you go for 1.6, you can get it anywhere. If you go from 0.5 to 1.3, there are 3 domestic producers. NSG has worked most closely with the projects that we've been involved in recent. Most of these folks are making that glass overseas. NSG is now making it in the US. So from a supply chain point of view, it's going to be easier. Can you handle it? Everyone you talk to says the first time they do it, they break, but after the second or third or fourth time, it's not a problem. So I want to go sideways for a second here. Flat screen televisions. How many of you have a flat screen television? Everybody. If you're not raising your hand, you're lying. Do you have any sense of what the volume of glass and flat screen TVs is compared to Windows? So here's a simple data point. This is approximately right. 50 million windows sold to homes last year. Each window is what, 12, 15 square feet average size, something like that. 40 million televisions sold to homes last year. Each of them is about 10 square feet roughly. So basically, the glass industry is putting as much thin glass into American homes every year as the window industry is, to within a factor of 2. That's your takeaway for the day, okay? So basically, now, it's not the same industry, I get that, or it's not the same fabricators, and the production line for making a flat screen television doesn't look like the production line for making a window, but the underlying technology to make the glass, to cut the glass, to ship it, to clean it, do everything you possibly want to do with it, it's out there. It just doesn't happen to be in this room necessarily. But that means that if you want to play with it, you just go to someone that already knows how to do it. You don't have to do research and start this stuff from scratch. Automated manufacturing. We've talked to all the IGU fabricators. They all say, we can do it. We have to tweak our design, our equipment a bit, to change the suction cups. We have to change, this or that. But again, this isn't rocket science stuff. This is engineering. They basically all say, if a customer comes to us and wants one of these plants, we'll design it for them. Spacers, this is taken from some literature. There's a couple of spacers out there. Now, these are the single spacers. If you want, the normal double spacers, no problem at all. We'd like to see more single spaces because we think there's an advantage there. There's a bunch of patent literature on this. There's a couple of products out there. Basically, there are options. And then one interesting thing is safety glazing. You can't temper thin glass. You can put a thin glue-on film on it, which can help in some cases. So basically, if you absolutely need conventional temper or need safety glass, this may not be what you want to do. Principally, you can temper down to 2.2, which we include in the thin glass world. But that's a bit tricky. So you guys know more about all that than I do. So let me just close by talking about sort of benefits. I've gone through the technology part. Comfort comes up. You were talking about it just a few minutes ago, I think. We've done a bunch of comfort studies here to say, can we sell better glazing? Can we sell these triples or VIGs on the basis of comfort? So we set up this room with a couple different windows in different sizes. And here's just a room with a single window or windows on one side. We vary the windows from small to large, 25% to 100%. And then on the vertical axis, we're going from single clear all the way down to triple. And this percent dissatisfied PPD comfort metric, dark blue is bad. That's all you need to know. Dark blue is bad, white is good. And so if you look across the top with single glazing, any amount of glass is uncomfortable. If you look across the bottom, any amount of glass is comfortable. And in between there, like in the middle, double low E vinyl, you're uncomfortable 2 or 3 feet from the window. If you're in the back of the room away from the window, you're not uncomfortable. There's different comfort issues going on here. There's radiative comfort, which is the surface temperature, and then there's an airflow. You've got a big piece of cold glass. You've got an air current coming down. It's called the ankle effect. Most of us have socks on, but if the air flows down, flows across there and makes you colder. So all this comfort work is pretty well defined. And I'll come back to this in a second. There are tools out there that can tell you for a given type of glass and a given physical layout, whether you'll be comfortable or not. This is a different metric on comfort. This is, minimum outdoor temperature at which you would be comfortable. And the bottom line here with my 2 arrows is if you're in Minnesota, if all you have is double pane, the window to wall ratio should be about 10% if you want to stay comfortable. If you make it bigger, you won't be as comfortable. If you're using triple pane, you can have an 80% glazed wall and still be comfortable. Again, it's a little more complicated than that, but you can begin to understand where these things have the most benefit and how much. So we've been doing a bunch of demonstrations to try to show that these things can be built, they can be installed, they save energy, and they help comfort. Here's a little map showing some projects around the US. This is some collaboration, DOE-funded work. These field projects are led by PNNL. There's a couple being led by LBL in California. California, interestingly, is spending some money on this, and you go, why are you going to do triple glazing in California? Berkeley Lab has $1.5 million contract to install these, and these are all retrofit, by the way, multifamily homes and single-family homes. But here's the reason. This is back to the new code. In the new code, they didn't mandate any change in windows, but they mandated a whole bunch of changes in walls. This one in the middle here, high performance wall, they've now mandated you either go from 2x4 construction to 2x6 or put foam on your 2x4. No builder wants to do that. It costs them $3,000 to do that. As an alternative in the code, look at the bottom trade-off, you can put in triple glazing. So if you're a builder, you got $3,000 you've got to spend here. If I can put in better windows, better triple glazing for $3,000, I'm ahead of the game. Well, it's a 2,000 square foot home, 300 square feet of windows, $10 a square foot. That's a no-brainer. The window guy says, yes, we can make windows at less than an added cost of $10 a square foot. So they've made some traction selling builders on the idea, build California homes with triple glazing because it's an alternative way to meet the code. And then one of the groups that we've developed, you've heard a little bit about this before from Tom, is to try to take the things going on in California and New York and other places and make them national. So this Partnership for Advanced Window Solutions, one of the first things it's doing is working on this triple glazing problem. This is being led to some extent by NEA in the Northwest Energy Efficiency Alliance, and they are running a new program up there. They'll launch it next year to try to push triple glazing to the market. That's going to work out well, I think, because it will coincide with the Energy Star program. And the other thing that this group is doing is try to help out in terms of finances by getting the utilities out there to offer incentives for better windows. So the idea is that in the first year or two, when the products are still a bit more costly than they should be, they haven't reached volume production cost, would be to try to subsidize the cost of it. So let me close with 3 or 4 slides here back on the commercial side. So I showed you this slide before, making the argument about integration across the windows to the HVAC. So here's an example. This is a group in Boston. I was thinking for what kind of building was this? Then I looked more closely at the picture, and there's an airplane taxiing out there. So this is obviously an airport terminal, but floor to ceiling glass, and you see all that metal stuff at the bottom. That's a perimeter heating system because you've got that floor to ceiling glass, probably double glazing. Hope it's not single. But if you want to be comfortable standing near there, you have to add heat at the edge because of the comfort issues we talked about before. This firm calculated that they could replace, or if they went to triple, they didn't need that heating system. And that basically, it was less costly to put the triple in than to put the heating system. So this same firm, Payette, developed an online tool that you can play with. And this will allow you to size your windows, size your type of windows, pick a climate, and then look at where you are in the room and a bunch of other things and figure out if you're comfortable or not. Definitely worth taking a look at. And so this is part of the last 2 slides here. This is part of the bigger picture of making the dollar case, the cost case for why one should invest more in what is seen as a costly building component. So you've seen these kinds of numbers before that energy costs, although they're a challenge, they're dwarfed by the productivity cost, by the comfort cost. I tried a new one here, this one in blue here, high performance glass, $15 a square foot once. So these other costs are annual costs. If you say, what does it cost to put a better window in? And you take that cost per square foot of glass, stretch it out to cost per square foot of floor, it's not a huge number relative to all the other numbers we're talking about. So if this gets any traction and you get an enlightened building owner, there's some hope maybe that the barrier to investment in better facades, first cost investment, will come down lower. If you talk to any of the big A&E firms out there, and you talk to any of the big people building stuff, Google and Apple and all those guys, they're all talking about building net zero buildings and net carbon and meeting all this good stuff. Whether they're doing it or not is a good question, but they're at least talking about it. And the AIA 2030, and all the big architectural firms say, you know, every building we do is going to be net zero, et cetera. You take all that with a grain of salt, but at least they're saying the right thing and moving in the right direction. So if we're going to get, I want to close on retrofit because I talked about the importance of that. We're going to get all that 50% of that stock fixed well before 2050. We need to retrofit. I won't go through the details here of why it's a challenge. But two different things. If you can afford to replace the facade or the glazing, the top two items here, great. That gets pretty expensive and pretty disruptive in terms of what goes on inside the building. So there's a lot of interest now in add-on glazings, both inside and outside. And here's a project that GSA recently funded. So GSA, again, owner of all the government buildings, Green Proving Ground. These folks have developed, this is Halpin that did that triple and quad window. They've developed an interior glass retrofit panel that's light enough for that woman on the right there to handle that full-size sheet. It's simply a piece of 1 or 1.2 millimeter glass with a thin sheet of plastic on it and an edge frame, and it can be retrofit rapidly without disrupting interior operations. It seals the window. It provides, as one version that's single, there's another version that's double. You can seal, I know that's the next slide. You can see some isotherms here. A simple solution to snap it into place, can be retrofit easily. And GSA just did a study of that in, 8 or 10 different climates. The bottom line here is this stuff has paybacks from 5 to 10 years. And 5 to 10 year paybacks are the kinds of paybacks that building owners like to see. They're saving 12 to 15% of the energy and paying back at that rate. So I think there are opportunities there's certainly opportunities in new construction. There are a number of opportunities in existing construction, and we need to take advantage of them more aggressively. So closing with the NGA theme, glass can at least help save the world. I buy into that. I think the challenge here is that we need to sort of have this combination of sort of marketing. We need to market what we have, and when there are gaps, do some innovation, some R&D that fills those gaps. I've given you some examples of what's been going on there. I think it's going to be critically important to package, in terms of getting owner response, to package all the occupant benefits with the energy carbon savings. Some of them will respond to energy carbon in dollars, but some of them will respond to these other issues as well. We need strategies for getting in different timeframes, and some of those strategies will be new construction, some will be existing building retrofit. So we need strategies for those retrofits. And I think the other thing that's come up a few times in the last day is this organization, or any glazing organization, and I'm involved with the facade tectonics folks and others, by itself, it's not going to change the world, but there's a lot of other groups out there, the Alliance to Save Energy, ACEEE, the New Buildings Institute, Institute for Market Transformation. All these groups out there are pushing buildings, and they want solutions. They want envelope solutions. They want help, and you all and others can partner with them and help. And I think most important is this stuff. It's not particularly easy, but we've got to stay focused on it and keep pushing ahead, which is why it's fun to come to meetings like this. So thank you for your time.
We hope you enjoyed this session. If you have specific questions, please feel free to contact Stephen directly using the email address on screen. Thank you for joining us, and we look forward to seeing you again soon at a future NGA event.